So we've established our graphical analysis. Now let's look at algebraic analysis. So we're essentially going to go through the same types of descriptions, but we're going to look at it algebraically instead of graphically, starting with functions. Remember that in order to be a function, every x value produces a unique y value. You can't have multiple y values being produced when you plug in an x. So another way of saying it then, if we look at an equation, is can y be isolated? If I give you an equation, you can't just say it is or isn't a function because it is or it does not have y by itself. If you can isolate the y, then we can say that it is a function. And on top of that, if you can isolate the y and still only produce one y value for every x, then it is a function. So let's look at these. Let me show you what I mean. So looking at these first three, I see that all of them, y is already isolated, so obviously yes, y could be isolated. But the question is, if I plug in an x value, do I get only one y value at a time? So if I think about this one, if I plug in x equals 7, square it, multiply it by 2, add 5, I'm always going to get the same answer. If I plug in -7, I'll get a different answer. Well, this time I actually get the same answer, but I could get a different answer, but that's irrelevant because positive and -7 are two completely separate input values. The point is, no matter what input value I plug in, I will always get the same answer for that input value. So this one is a function. Same thing on this one. If I plug in an x value, I only get one answer for my y value, so that one works. Same thing with this one. If I plug in an x value, I always get the same answer on my y value. So that one works as well. Now it's important to remember on this one that square roots. There's often confusion. If I were to plug in a number, let's say 3, 3 times 2 is 6, 6 plus 5 is 11, square root of 11, then you might say, well, shouldn't it be positive and -11? And the rule to remember is, if the square root was already there, then it's implied to be either positive or either negative. The fact that there's nothing up front tells me that this is a positive square root. If I wanted it to be negative, I would have put a negative up there. The only time when you have to worry about positives and negatives is when, for example, you have x squared equals 4. X could be either positive or negative. So if you have to take the square root to get the answer, then you have two separate possibilities, positive and negative. But if the square root was already there as part of the problem, then there's only one answer. For instance, up here, if I plug in an x value, the y could either have a positive or a negative and be the exact same thing. If I were to isolate the y, if I were to take the square root over here, taking the square root would require a positive and a negative, versus down here, I didn't take the square root was already there, and it was implied to be positive. Here, if I plug in an x value, there are two separate possibilities for what that y value could be. Therefore, this one is not a function. Same thing here, absolute value around the y instead of around the x. We talked about this last time. The way to get rid of that absolute value is to drop it and make it two separate problems. We have positive 2x plus 5, but we could also have negative 2x plus 5. So dropping an absolute value is pretty much the same as getting rid of a square. That's to put a positive negative on the other side. So that one doesn't work either. Now this one is not currently solved for y. The only thing I'd have to do to solve for y is just divide both sides by x. And when I did that, the y would be by itself. I would have 2x plus 5 over x. It's an ugly function, but that doesn't change the fact that if I plug in an x value, I'd only get one answer for y. So this one actually does work. So there are common tricks, common shortcuts to identify whether it is or is not a function. If y is being raised to the first power and there's nothing else going on with the y like the absolute value, then it works. If y is being raised to the second power, that means you would have to take a square root, which would involve positive and negative, which means it's not it's not a function. So essentially, if it's an odd power on the y, it works. If it's an even power on the y, it doesn't work. And then, of course, absolute value around the y, that's another special case where it doesn't work. You can have absolute value around an x, but not around a y.